Hello, my name is Ecieno Carmona, and I'm a student with Florida Polytechnic University, and I'm on the UV water filtration project using titanium dioxide as the catalyst. Over here is our batch reactor that was actually 3D printed at our 3D printing lab here at the school. And as you hopefully can see, we have it going right now with the bubbles providing oxygen in there. I'm going to close this up for right now because it does use UV lights, which can actually harm your eyes, which is why we're wearing safety glasses here. Let's turn this on. All right. Well, as you can sort of see, it's spinning in there. You have the bubbles coming through the case a little bit. Let's talk about the design here a little bit that we have. This was actually the initial sort of prototype that we had. As you can see, it sort of exposes the whole thing, so people working in the lab would actually always have to wear the UV glasses. With this case design, it sort of keeps it all enclosed, so again, people can work in the lab without having to wear the glasses constantly. Up here on the top, we have a tubing for water flow, so that way it works almost like a radiator in a car, and it uses to cool down the water inside of here. To make the titanium dioxide work correctly with the catalyst, you need oxygen. So we have an air going into the solution, and of course it helps the titanium dioxide work. This right here is the titanium dioxide. So a white powder that we use as the catalyst. We mix this in with the water and the methylene orange. We use that at 20 ppm, which is 20 parts per million. And as we run the process, we of course test it. As you can see, we go from 0 minutes to 15 to 30 to 45 and so on. And it eventually goes from the mixture to a more clear solution over here.
This one is more.
Oh, that's more? Oh. And as we continue on, you can see more of how it gets clearer and clearer. To test it, well, I was going to get to that. Okay. But to test it, we take, of course, a syringe here, and we go into the hole, which is a little bit hard. Go in. And then we have this, and of course, then we put it in a test tube. But of course, this is just for demonstrations for right now. After the experiment, we are actually trying to recycle the titanium dioxide. So right now we have, from a previous experiment, some inside of this little vial. And we will separate it, the moisture and the water from it, and try to reuse the titanium dioxide. And then, of course, because this is 3D printed and plastic, we have to check the temperature and just check the temperature of the internal temperature to make sure that things are not overheating. We have the outside temperature, which is actually reading 30.6 Celsius, and the inside temperature at 39.7 Celsius. So they are well within range of what we need for the experiment.
I'm Dr. Sesha Srinivasan. I'm here at Florida Polytechnic as a professor of physics and engineering. And this project, what our student demonstrator, Ecieno, demonstrated on the water purification, water filtration project. He successfully demonstrated and also fabricated this 3D printed design for water purification. But what is the basic underlying mechanism of water purification? Because there are many filters available in market. They may have UV filters with reverse osmosis filters and many other filters. But many of the chemicals, Ecieno demonstrated that methyl orange. Methyl orange is such a chemical like azo dye or methylene blue or methylene red. They all used for fabrics in textile industries. They completely miscible in water. So In order to separate from water, you have to chemically disintegrate this. Because of eventually this project will merge into using a solar light, sunlight as a source of energy for water purification. That way many of the underdeveloped and developing countries, we use this design so that we can use this as a water purification project. So in this project we used the photo oxidation of chemicals. Photo oxidation of chemicals, basically the contaminants, if you look at the contaminant like methyl orange or methylene blue, they are all very highly complex molecules, many bonds and many covalent bonds. So in order to disintegrate this complex molecule, you have to work chemically treated by using catalyst. So we have recorded based on this Ecieno setup, we did some measurement done on water level of purification. If you look at the methyl orange degradation at 0 minutes, we got the fingerprinting of the molecule stretch that's around 464 nanometers. Whereas if we take the sample and then this measurement was done under the UV visible UV spectroscopy. So this measurement shows that around 240 minutes you can completely disinfect or disintegrate the chemical over a time. So that's the same thing for methylene blue or methylene red, but we wanted to emerge this project to use a sunlight as a source of energy and then disintegrate the water purification. Overall, it's a lot of material science, engineering aspect, design aspect is going into this project. So with this summer, we would like to demonstrate that proof of concept of the using a water, decontaminated water, either from the lake side or pond side. Then we will use this technology to purify. That will eventually emerge into sustainability and renewable energy course, which will be offering in fall 2016 at Florida Polytechnic. Thank you.